Zoom that in a little bit. All right, guys. This lesson should be pretty short today. Okay, so if we can get through it quickly, you should have a good amount of homework time. Okay. So I've sort of been previewing this lesson for the last couple of lessons, really. We're going to talk about how to graph equations when they're not necessarily given to you in slope-intercept form. Okay? And our goal today is that I could hand you any equation written any way, and you could find a way to get it on a graph. Now, you do always have the option of putting it into slope-intercept form. And there's some people that want to ignore everything that I'm saying today and just always, for the rest of their life, put everything into slope-intercept form. And if you love putting things in slope-intercept form, more power to you. Okay? You are welcome to do it that way. I'm hoping what I'm giving you today, though, is sort of a shortcut for that. Okay? So today we're going to be looking at equations that look like this up here, if you see in the title, the ax plus by equals c. That is what's called standard form of an equation. So standard form looks like this, just to recopy what's at the top of the page, where a, b, and c are all integers, meaning they're numbers. And you've seen equations that are written this way, right? Like you've seen like 5x plus 2y equals 10, something like that. Okay? And up until now, when we've had that, the only way we've been able to graph it is to rearrange it and get it into slope-intercept form. Okay? Good with that? Any questions there? Understand where we're going today, hopefully. Okay. So the way we're going to graph something like this, or even something that's written in like, because you could write a linear equation that's not in slope-intercept or standard form. You could write a linear equation that looks like whatever you want it to. If it's written in any form, you should be able to graph it by finding the two intercepts. Now, you right now know how to find the y-intercept as long as it's in slope-intercept form, right? But what I'm showing you today is a more general thing that would work for any equation written any way, it happens to be written. Think about the x-intercept. So think about, can't see that, can you? Think about like a line like this. Here's your x-intercept, and I want you to think about what do you always know is true at that x-intercept, no matter where it's located.
Y equals 0.
The y value is 0, right? At the x-intercept, y is always equal to 0. Okay? Which means at the y-intercept, what do we know? X equals 0. Okay? And that is a question I'm going to ask you 1,000 times between now and the test. Okay, is because you're going to be asked questions about, well, what's the x-intercept? What's the y-intercept? And I will always just say to you, okay, what do you know at the x-intercept? And by the way, that works for problems other than linear equations as well. Quadratics, when we get into quadratics, exponentials, any type of equation I give you, if we're looking for x or y-intercept, this is how you always start. Okay? Okay, so let's take a look at this first example, and these are probably in your example packet, I would think. Okay, we want to find the x and the y-intercept of each of the following. Okay, so I really have to do like two separate problems here. One to find the x-intercept, one to find the y-intercept. So let's start with the x-intercept. At the x-intercept, what do I know is true? Y equals 0, right? So for the x-intercept, y equals 0. So that means I'm going to plug in a 0 in place of y. 0 equals negative 5x plus 2. So I made the y equal to a 0. Okay? And then what do you think I'm going to do? Solve it. Yeah, and I'm going to have to move this over. I didn't give myself enough space. But so 0 equals negative 5x plus 2. And I would minus 2 from each side. So I end up with negative 2 equals negative 5x. Okay. And then I would divide by my negative 5, divide by my negative 5. And I could leave my answer as 2/5, or I could say x equals 0.4. Okay, but that's my x-intercept. And if I wanted to write that as a coordinate, that would be 0.4, comma 0. Okay, right? Because we're saying this is what x equals when y equals 0. Okay? You good with that? All right, the y-intercept is going to be easier. You should be able to find the y-intercept right now, right? Because that's in slope-intercept form. Can we cut the chatter, guys? So this is in slope-intercept form. You should be able to look at it and tell me what the y-intercept is. But we can still use the same process. At the y-intercept, what do we know? X is 0, right? So if I plug a 0 in for x into my original equation, it would look like this. Y equals negative 5 times 0 plus 2. Well, what's going to happen with negative 5 times 0?
It's going to be 0.
Yeah, it's just gone, and I'm left with y equals 2. There's my y-intercept. Okay. How would I write that one as a coordinate? Good. 0, comma 2 because the x is the 0 this time. So 0, comma 2 would be that one written as a coordinate. Okay, so no matter how your equation is written, this process will work. Okay? All right. This one down here, 5x minus 4y equals 30. And gosh, I might go to the back of my page here so that I have room to do this. What was it? 5x minus 4y equals 30?
Yep.
Okay. This one's written in standard form. I'm going to write this one out the long way, and I recommend that you do the same. But I'm going to show you that with these ones, when they're written this way, this should be, like, there's a shortcut for it. Okay? But we're going to write one out the long way. So let's start with the x-intercept. At the x-intercept, what do I know? Y equals 0. That's right. At the x-intercept, y equals 0. So I'm going to plug in a 0 for y. 5x minus 4 times 0 equals 30. Well, then 4 times 0, I really don't need that, right? So that's gone. And so I end up with 5x equals 30. Divide by 5, and I end up with x equals 6. Yep. So my x-intercept is a 6. And then if I repeat the process for the y-intercept, at the y-intercept, x is equal to 0.
7.5.
What's that?
7.5.
That's right. So I'm going to put, 0 here. So 5 times 0 minus 4y equals 30. You were almost right, Daniel. One thing you missed. That's a negative 4y, right?
Yeah.
So when we divide, that's going to give me a negative 7.5. Follow that okay? Okay. Okay, so we can find intercepts of anything, right? Shortcut for when they're written like this, what I usually do when I'm looking for the intercepts, especially if I'm just wanting the intercept so I can put it on a graph, is I say to myself, okay, when I want the x-intercept, I know y is 0, so I just cover up the y. And I just look at that and I say, okay, 5x equals 30, so x equals 6. I don't write any of this down, okay? If you want to write it down, you can. And I suggest that you write it down in your notes so that you have it to refer back to. And then like when I'm looking for the y-intercept, I cover up the x. You do just have to remember that that is a negative 4y, okay? Do 30 divided by negative 4, you get your negative 7.5. And then what you can do, and we're going to do this in the next example, but the way you can get that on a graph now is you can say, all right, I know the x-intercept is 6. So I'd put a dot at x equals 6. I know the y-intercept is negative 7.5. So that would be like here. And once you have those 2 points on the graph, you can just connect them and make a line. Okay? So you don't have to mess around with slope. You don't have to mess around with rise over run. If you can get those 2 points, you can just put them on the graph and connect them. Okay? Does that make sense? The one thing you want to be careful of, this happens sometimes, is people want to put these two things together and make it like one coordinate. They want to make it like 6 comma negative 7.5. Remember, these are 2 separate points. This is like 6 comma 0, and this is 0 comma negative 7.5. Good? Okay, let's go do that on this next example. Oh, look at that. I just did this. Use the intercepts to graph the second equation above. Okay, that's one we just did. So that's where we found our x-intercept to be 6, our y-intercept to be negative 7.5. I didn't realize that was on there. So I'm just going to do it more officially here. X equals 6. goes right here. X equals negative 7.5 would be halfway between here and here. Okay, and then draw your line. Okay, and so that's how I think it's easiest to graph those equations, especially if you do kind of that shortcut where you just cover up one, cover up the other, and grab those numbers really quick and then just put them on the graph. Okay, and again, if you really wanted to switch that around to slope-intercept form, you would get this as your y-intercept. You could do rise over run, and it would give you the exact same line. But I just happen to think it's quicker. Good with that? Okay, a couple more things we're going to jot down here. We're going to talk about 3 types of lines. We've already sort of talked about, well, at least 2 of these, but so types of lines. There's oblique lines, there's horizontal lines, and there's vertical lines. Okay? Anyone know what oblique means? Emily? Yeah, slanted. Okay? Most of the lines we work with are slanted, right? They're diagonal. Those are oblique lines. So an oblique line looks something like this. I mean, it can be located anywhere on the graph, but it's just anything that's diagonal. Okay? And oblique lines will have both x and y in their equation. So most of the equations you deal with have both an x and a y. Okay? So most of the lines you deal with are going to be oblique lines. And we can write these in either slope-intercept form, or we can write them in standard form. Whoops, that's not y equals then. Standard form looks like this. ax plus by equals c. And notice these both have a y and an x in them. X and y. Okay. Now we've talked about intercepts today. The problem we run into is when it's written in this form, the slope is not as obvious. And be really careful here. If you think about this equation back here, the 5x minus 4y equals 30, that's in this standard form. I have a lot of people who, if I ask them the slope, they want to just tell me that it's 5. And I see why you're saying that, because it's always just been the number that's in front of the x. But in this case, you have to rearrange this equation to slope-intercept form to be able to see the slope. But there's a shortcut for that. Let's just take this general equation, this ax plus by equals c, and let's rearrange it to be in slope-intercept form. So if I wanted this to have y by itself, what's the first thing you would do? Let's go back to numbers. They're less scary than letters. In this equation, if I wanted to put it in slope-intercept form, maybe I'll just do this down here. Okay, 5x minus 4y equals 30. If I wanted it in slope-intercept form, what's the first thing you would move out of the way? The x. How would I do it? Yep, minus 5x. Minus 5x. Okay, so I end up with negative 4y equals, this is going to kind of nudge its way in front of the 30, so negative 5x plus 30. And then?
You divide by negative 4y.
Yep. Just negative 4. Yep. Divide by negative 4, divide by negative 4. Okay. And notice this right here is going to be your slope. Now, the fact that they're both negative, what does that do to it? Makes it positive, right? So we would say in this one, our slope is 5 over 4, right? I want you to look at that compared to the original equation. Do you see the relationship between the numbers there? That every time you do this process, you're going to move this number over to the other side. So when you move this to the other side, it's going to become negative. What if it was already negative? Okay, so whenever you shift that x to the other side, it's going to become the opposite of what it was before, right? And then we're going to end up dividing it by whatever's in front of the y. So if I asked you for the slope of this equation, couldn't you just do that with the numbers instead of having to go through all of this?
Yeah.
Does that make sense? You could just say, okay, I know that's going to become a negative 5, and it's going to end up getting divided by that negative 4. So it would be negative 5 over negative 4, which I know is going to reduce to 5 over 4. Okay? So let's look back at the letters now, the scary letters. if I put this in slope-intercept form, I would subtract ax from each side. Do you agree? Yeah. So I end up with by equals negative ax plus c. Okay? And then what would I do? Divide everything by the b. Okay? And you see what ends up happening is in front of the x now, where the slope should be, you get this negative a over b. So anytime your equation is written in this form, the ax plus by equals c, you can find the slope by doing negative a over b. And that's just what we were saying a minute ago, is you would take the a number, it's going to be opposite because it moves to the other side, and then you end up dividing by whatever's in front of the y. And that right there, I would highlight that or circle that or something. This is a trick that will save you a lot of time and a lot of grief, and people forget about it a lot. Okay? When I hand you an equation that's written in this form and I say find me the slope, I have a lot of people, either they tell me just the number that's in front of x, or they stare at it and go, I don't know how to find the slope, or they go through this process every time, which nothing wrong with going through that every time, but you can just grab those two numbers out and stack them and make them a fraction. Okay? Emily?
I don't get how, like it keeps turning into a negative.
Okay.
At the top.
It becomes a negative because to get it in slope-intercept form, whatever this x is, you would have to move it to the other side. And the way you move it to the other side is by doing the opposite of what it was to begin with. So like, if this was positive, I would subtract it so that when it shows up on the other side, it's negative. If it was negative over here, I would add it, and then it would be positive on the other side. So it's always the opposite of what it was before. Does that help a little bit? Okay. Let's maybe do a quick example of that. I'll just slide it in up here at the top. Let's say I gave you 2x minus 3y equals 15. And I wanted the slope. Just the slope out of that. How would you get it? Thinking about this thing I just highlighted down here. Okay, so it would end up being negative a, right? Because this 2x would move to the other side and become negative. So it would be negative 2 over negative 3. But then what happens when I have two negatives? Cancels, right? So it ends up just being 2/3. That's your slope. You see how that works? Okay? Then you can just grab those numbers and stack them, but your negatives are going to switch. Okay? If it was negative to begin with, it's going to become positive. If it was positive, it would become negative. Okay? When it's written in this form, the slope is just m, right? So you can just grab the slope from there. But when it's written in this form, you do have to do a little bit of work. Okay? Okay, let's talk real quick about horizontal lines. We've already talked about these. Horizontal line looks like this. What do these equations look like? Yep, Emma?
It's always just y equals a number.
Yep, so there is only a y in these equations. Anytime you only see a y, that's going to be a horizontal line. It's going to be y equals some number. Okay? What is the slope of a horizontal line? 0. It's flat. Yep. So the slope is 0. And this set of information right here, the fact that it's a horizontal line, the equation, and the slope, I would do your best to just group those things in your mind and memorize them. Because it's just going to make your life so much easier than if you're always trying to like figure it out. Okay? So what do you think, and we haven't talked about these yet, but what do you think a vertical lines equation is going to have in it? Only an x, yep. Okay, so these equations only have x. They're going to be x equals some number. Does anybody know what the slope of a vertical line is going to be? Seth?
Undefined.
Yeah, it is going to be undefined. And here's why we say it's undefined. By the way, undefined is not the same thing as 0. Okay, 0 means it's flat like this. Undefined means it's standing up straight. if your equation is x equals a number, let's just say it was x equals, I don't know, what's your favorite number? What do you want to use?
2.
X equals 2, okay? Give me some coordinates that would be on that line. If I'm saying that x has to equal 2.
2, 3.
Sure, 2, 3. Give me another one.
2, 4.
2, 4. Good, nice and easy for me. Let's suppose I wanted to find the slope using those points. Okay, so I'm going to do my y2 minus y1 and x2 minus x1. So I would do 4 minus 3. Those are my y's, right? Over 2 minus 2. What ends up happening here? Yeah, I'm going to get something on the top, and it's going to be different depending on what points you choose, but something on the top. But it'll always end up being over 0 because your two x's are the same. So when you subtract them, they're going to make a 0. And this is what makes the undefined slope. Okay? So a vertical line, it's going to be x equals a number, and it's going to have an undefined slope. And again, as soon as you see this equation, I want your brain thinking it's undefined. Okay? Let's talk intercepts real quick on these horizontal and vertical lines. A horizontal line does not have which intercept? It has this, which is the what? That's the y-intercept, but it doesn't have an x-intercept, right? So maybe we should jot that down too, is that these have no x-intercept. So when you're asked to find an intercept, it just doesn't have one. That's not the same thing as 0. You don't want to say 0, because 0 means it's actually crossing at 0. Okay, you just say it has none. So then what do you think we could say about the vertical line?
It has no y.
Has no y-intercept, that's right. So, no y-intercept. And again, we would not say 0. Okay, you would just say none. Because there are going to be some questions on your homework that ask about that. Emily?
What happens if the line is on top of the axis?
It's a great question. It would either be x equals 0 or y equals 0, depending on which, like if it was this kind of line or this kind of line. So, yeah, that's how that would work. Very rarely do we graph things like that, though. So, you know, your line shouldn't end up on top of your axis. Because sometimes what people do is they'll say, okay, my y-intercept is at 5, but then they want to graph their line going up and down. You don't typically want to graph on top of the axis, okay? Any other questions on any of that? We ready to jump into homework? Okay, homework is in your packet. Let me see if I have one here that I can kind of demo with. No, hold on. Lesson master 3-4, yep, 3-4B. I'm doing this more for 6th hours benefit than yours, but 3-4B, I just want to clarify something here. In this table that you have, so it's asking you to find the slope, the y-intercept, and the x-intercept of all of these equations, and then I added these two things in here because you need practice with those. That's the slope of a parallel line and the slope of a perpendicular line. So if you got your slope for this one, how would you get your parallel line slope?
It's the same.
It's exactly the same. So really this whole column should match this whole column. Okay? The rest I think you should be okay on. Yeah.
What do you want us to do for number 10?
Number 10? Okay, so thinking about what we just said here, like for a horizontal line and a vertical line, what did we say the slopes were?
Oh.
Okay? And then for an oblique line, I just want you to tell me how did we calculate the slope? Like what's our little formula for it? Okay? Okay, yeah, you should be good on the rest. The rest of the time is yours to work on that assignment. And hopefully you can get it done so you can enjoy some Halloween festivities tonight. Okay?